Hey everybody, Mac here, and we're going to do some systems of equations we're going to solve by substitution. This is version B. We did have a version A, and if you haven't found that, you can go to maxtutorials.com and see lots of videos there. Just like and subscribe this, it would help me out a lot. Now, in version B, we're just going to do the same thing we did in version A. Some of them are going to be a little more difficult, but as you remember, these are set up with a y equals or an x equals. Well, what does y equal? Y equals all of that. So just if that said y equals 3 and I would plug 3 in for y, well, y equals a bunch of stuff. We're just going to just put in a bunch of stuff for that y. So I'm going to rewrite this equation now, but I'm going to write it, instead of x, I'm going to write it like this right now. So there it is. X plus y equals 12. Well, instead of y, what is y? Is 2x plus 3. Okay, now it's good to do it in parentheses because sometimes there's something in front of that. Now in this case with the plus, it doesn't mean anything. So we're just going to now combine like terms, and I'm going to get 3x plus 3 equals 12. And then we're just going to solve the equation. And again, I know I'm going, oh, what was that? And I know that I'm going really quick here. Go back to Unit 2 at maxtutorials.com, and you'll see how I do that. So if this part's a little confusing to you, that's okay. But go back to that Unit 2 and it'll help. So now I've solved and I get x equals 3. So all you have to do is take that x and plug it right back in. Now you could plug it into either equation. You could plug it into that, or you can plug it into that. Actually, it looks to me like that one's going to be a little bit easier, huh? 3 plus y equals 12. Subtract 3 from both sides. And I'm going to get y equals 9. Now, what you can do, we know that it works for this problem right here, right? But does it work for this one? And then you can plug in the x, and you would get, well, 6. What's 6 plus 3? 9. What's y? 9. It works. Okay? So now that we're in version B, they're going to be a little more difficult. We'll have a few more negative signs. So let's just start messing with this. So right here, we get y equals blah. Okay, so whenever we have a y equals or an x equals, that's the one that we circle and then we put into the y. So I'm going to write 3x plus parentheses. Now I plug in the x plus 4, and that equals 8. Make sure that's a negative x, okay? So now with a plus in front of a parenthesis, it doesn't change anything, so we just treat it like it's not there. 2x plus 4 will equal 8. Subtract 4 from both sides. Boom, die. Letters on one side, numbers on the other, which is why I did that. Now I'm going to divide by the coefficient. X equals 2. Bing, bing, boom. Got it. So now I can plug it into any one. Doesn't matter which one. I'm going to plug it into there. And I'm going to get y equals negative, what's x? 2 plus 4. And then I'm going to get y equals 2. And if you want, you can plug both of them back into this equation. And I'm just doing it in my head, and I can see I'm right. But again, if you want to really make sure you're accurate, those are things you can do. What if you're on a test and you forget how to do this? What would you do? Well, I wouldn't call this a cheat because you had to use intelligence and math to do it. You're not like copying it on a piece of paper. But what you could do when they give you, A, B, C, D, and they'll give you like a, I don't know, 3, 2, you could just plug in these numbers until you find out which one is right and never even do the math. Now, that's going to take longer, honestly. Well, unless the answer is A, right? But if the answer is D, it's going to take you longer than actually knowing how to do the problem. So I strongly suggest you don't do that. But if you get stuck and you're in a pinch, that's something you could do. All right, let's finish this problem. So 2x plus x, that's going to be a 3x minus 5 equals 10. Letters on one side, numbers on the other. So I'm going to move the 5 by adding it. I'm going to get my 3x equals 15. Divide everybody by 3, and now my x is going to equal 5. Boom. Plug it back in, and I'm going to write y equals, what is x? 5 minus 5, y equals 0. And there's my equation. Sometimes I'll write it like this. 5 comma 0, and I know that it's an ordered pair. This is going to be my x, that's going to be my y. So if you see it on an answer key, it can either look like this, or they may just write it like that. Okay, either way works. Y equals blah, so I circle my blah, and I plug it in for y. Now the parentheses is going to be super important on this one. 2x minus. Now, what is y? It's 3x plus 1, but remember, always write it in the parentheses. I know in the first 3 examples it didn't matter, but on this one it's going to, and I'll show you why. If you go back, and this was also in my unit 1, it was something called combining or adding, subtracting polynomials. We learned that if we have a negative in front of a parenthesis, that's like a -1. It's not like a -1, it is a -1, right? Okay, because there's like a 1 in front right there. Okay, we're just going to multiply by both, and I'm going to get -3x, and here's the part people miss, -1, because a negative times a positive is a negative. A lot of times people will get that first one and write -3x, but they'll forget to do the 1, so be very, very careful of that. When I combine these, remember that whole add a line, change the sign thing, I'll get a -1x minus 1 equals 4. When I add 1 to both sides, I'm going to get a -x equals 5, which means that x equals -5. Switching signs is the same as dividing by -1. Okay, I can plug it into either equation. I'm going to go ahead and plug my x into here, and I'm going to get y equals 3 times 5 plus 1. Y equals 15. What is that? I went a little ahead of myself. 15 plus 1. Y equals 16. Boom, 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 boom. Okay. And it looks like, let's see if I did that right. Something looked a little funny to me. And it did, because I plugged in a 5. I should have plugged in a -5, which makes that a -15, which makes this a -14. Now, what I didn't say is I went back into this equation and I plugged them back into my head, and I went, wait, that doesn't feel right. Okay, and it did, and it wasn't. So that's why I went back in and took a look at it and saw that I just missed a negative, and I got the answer right. Okay, so watch for that. Be careful. Circle. Plug it in there. Okay, so now I'm going to get I'm going to write this equation, x plus 2 parenthesis. Now I'm going to plug that in. -x plus 9 equals 15. Now, I've got that 2 in front. I have to do distributive property to both. I'm going to get x minus 2x plus 18 equals 15. I'm going to combine my like terms to get -x plus 18 equals 15. I'm going to get letters on one side, numbers on the other. We've been doing this again since chapter 2, and that's going to become a -3. And so my x is going to equal a normal 3, a regular 3. What's the right word? Positive 3, right? Boom. Plug them in. Y equals negative, what's x? 3 plus 9. Y equals 6. And looking up here is 3 plus 12, 15. Sure it is. Okay, we got it right. All righty, so let's go to the other column. We're halfway done here. It's a way to stay in there. So we're going to take my blah, y equals all of that. So let's plug it in. So I'm going to write this equation over here. 2x plus, and I'm going to write all this. -x plus 6, boom, equals 10. A plus in front of a parenthesis does nothing, so I just continue on. X plus 6 equals 10. And now once I subtract my 6 from both sides, I got letters on one side, I got numbers on the other side, which is what we want, and my x equals 4. Now, all we have to do is plug it in, and I'm going to get y equals -4 plus 6, y equals 2. Boom, okay? And again, if you'd like, you can plug all these into here and see if it works in there. And just me doing it in my head a little quick, which is dangerous, but I did, and I got it right, okay? Here we go. Now on this one, well, I think in my next version they'll show you, just so you know, you could do this. -y, x equals 13 minus y, and you could take all that and you could plug it into the x. I'm not going to do that, but I just wanted to show you that that could happen, because every once in a while you'll get equations. Oh, what happened there? That was a little bit crazy. Sorry, guys. There we go. Arr. All right. So I'm going to circle my blah, and I'm going to plug it into y. And so I'm just going to write this equation out here. X plus, now instead of y, what am I going to write? 4x minus 2, because that's what y equals. And that's going to equal 13. And we're going to get 5x minus 2 equals 13. We're going to get letters on one side and numbers on the other. So I'm going to get 5x equals 15. And then once I divide everybody by 5, my x will equal 3. Now I can plug it into either one. I'm going to go ahead. You know what? I'm going to plug it into this one. I haven't really done that in a while. And I'm going to go, well, actually it's x. It's, I I wrote x equals which is, sorry guys, got to plug it in there. 3 plus y equals 13. Now, once I subtract 3 from both sides, I'm going to see that y equals 10. It certainly works in this problem. And as I look in here, 3 times 4 is 12. 12 minus 2 is 10. Yay, I win. Number 8. Oh dear, I've got that dreaded fraction. Okay, well, that's all right. Let's just plug this in and see what happens. Let's just get going on it. Let's not make judgments. Maybe it's okay. I'm just plugging in. I haven't done any math yet. I just plugged in all that for y. Okay, now I'm going to distribute this -1 to both of these. And I'm going to get x minus 1/2 x plus 1 is going to equal 7. Okay, so now once I combine these together, I'm going to get basically what's 1 minus a half? Well, it's a half. 1/2 x equals 6. Once I multiply each side by 2, I'm going to get x equals 12. Okay? I'm going to plug my x into there. I'm going to get 12 minus y equals 7. Minus 12 minus 12. Boom, die. Negative y, that's something you may miss. Remember, that's a negative y. Add a line, change the sign, equals a -5. Or y equals 5. All right, is 12 minus 5 7? Sure is. What's half of 12? Well, it's going to be 6. Is 6 minus 1 5? Sure is. We win. All right, let's go to number 9. Here I'm going to take y equals blah, and I'm going to plug it into the y. Now I'm going to take this whole equation, and I'm going to write it out right here. X plus, now I'm not going to write y. What am I going to write instead? Negative 2x plus 7. Don't forget that negative. And all of that is going to equal 1. All right? Now I have that plus in front of the parentheses, so I'm just going to combine. Negative x plus 7 equals 1. Once I subtract 7 from both sides, that's going to be negative x equals a -6, or just x equals a normal everyday positive 6. Plug it back in. Let's just plug it into here. Y equals a -2 times 6 plus 7. Y equals a -12 plus 7. Y equals -5. Boom. And I can see up in this one, yep, that certainly works. And what's half of 6? Oh, sorry, what's -2 times 6 is -12. -12 plus 7 will give me -5. Hey, that's what I wanted. Cool. Last one. All right, y equals x plus 2. I'm going to plug that in for my y. And again, always keep the plugging in with parentheses because you never know when it might matter. And guess what? It's going to matter here. Okay. So if you just plug that in without parentheses, you would get a wrong answer. I promise you would. Okay, so always use the parentheses because now I see a parentheses, a negative out in front. So the negative goes to the x, which you would have got anyway, but you would have missed this one right there. That minus goes to both of them. Okay, and so we get 4x minus 2. You would have written plus 2 if you didn't do the parentheses. That's why it's so important. Okay. Boom, 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 boom. And I'm going to get letters on one side and numbers on the other. I'm going to add 2. Boom, boom. Die. 3x equals 15. Divide by 3. Boom, boom, boom. Die. X equals 5. Now we're just going to plug it in. We're going to go right there. Okay. Y equals 5 plus 2. Y equals 7. Just kind of take a gander at the other one. 20 minus 7 would be 13. Yep, we win. Okay, so there's some substitution. And so now remember, this only works if you get y equals whatever, or you get x equals whatever. You could then circle this and plug it into the x value. Now, there was no examples of that, but you could do that as well. If there's numbers in front of those, if there's coefficients in front of those y's and x's, this strategy won't work. Okay, so you just have to take a look at the question and the way they set it up. And then if they set it up this way, substitution is a great choice. All right. So there's version B. If you get it, that's great. And we will have to exchange them a little bit on version C. So it may be good for you to take a look at that as well. All right. Thanks, guys. I'll see you there.